Here, our value of a in the general form, remember the general form is f of x equal to ax cubed plus bx squared plus cx plus d. So this a here, this a, it's the coefficient of that term, okay, which is going to be equal to 1. Then, yesterday I introduced another general equation that you can use to determine the equation of a cubic function or the equation of a cubic graph. And that equation was y equal to a times x minus x1. Right, I'm going to write the general one. Then x minus x2 and x minus x3. Right, this is the general one. But remember, this equation, you can also have a case where x1 and x2 are equal, which means we won't have x3 in that case. We only have x1 twice and x2. Remember that I discussed that with you yesterday, right? So, for you to be able to find the values of b, c, and d, you need to use this equation, this one here. You use that one, right? So what you are going to do is substitute the a, we put 1 there because that's the coefficient of x cubed, right? Where there is x, we don't put any value. Where there is x1, for this question, I'm just going to follow the order of the values. But you can write them in any order. You still get the same answer. So my x1 will be minus 2. So that will be minus 2 times. My x2 is going to be 1. So that will be x minus 1. Right? And then my x3 is going to be a 4. So I'll have x minus 4. Okay? So that's how you start doing the question. The rest is algebra. Grade 9, grade 10. Okay? So this becomes y equal to, this becomes a plus, so we end up having x plus 2 times x minus 1 times x minus 4. Alright? The objective is for me to remove the brackets until I get an equation of this form, ax cubed plus bx squared plus cx plus d. Then I can be able to identify the values of b, c, and d. Right? So let's use FOIL here. So x times x will give me x squared. X times minus 1, that will give me minus x. Positive 2 times x will give me positive 2x. Positive 2 times minus 1 will give me minus 2 times x minus 4. Alright? I expect you to know how to do this because you did grade 9, you did grade 10. Okay? Then this becomes y equal to, if I simplify here, minus x plus 2x will give us positive x. So you end up having x squared plus x minus 2 times x minus 4. Right? Now, if you did the homework, by now you can see what you did wrong and what you did right. That's the advantage of doing the work. If you didn't do it, you are blank. You are seeing this for the first time because you haven't attempted any question. Then x cubed times x, that will give us, sorry, x squared times x, that's x cubed. X squared times minus 4, you get minus 4x squared. Positive x times positive x, that's x squared. And then x times minus 4, that will give us minus 4x. Minus 2 times x, you get minus 2x. Minus 2 times minus 4, you get positive 8. So if you did the work, you can see whether you did the right thing or not. Then let's simplify that. So our final answer will be y equal to x cubed minus 3x squared minus 6x plus 8. Okay, so that's the final equation. And I want you to be aware that this equation, it starts with f of x, but mine starts with y. It's the same thing. You don't have to get confused. Why is going to write a y, but there is f of x. It's the same thing. Okay? Then you say, therefore, let's compare the coefficients now. The coefficient of this one here and the one that I just got. Right? The coefficient of x cubed is a 1 here. but we don't want the value of A. So our value of B is going to be equal to minus 3. The value of C is going to be minus 6. And the value of D is going to be positive 8. So these three will be the three values. All right? So if you did the way, mark your way. All right? So that's what you're supposed to get. Is there anybody who has got any question? Is there anyone who has a question? All right. If you don't have any question, then I'm going to carry on to the next one. That is 9.2. So this is 9.1. All right. 9.2 now. Now, in most cases, these questions have a connection. I need you to be aware of that. If you don't get 9.1 correct, you are most likely to get 9.2 incorrect. Because those values of B, C, and D, you need them to do 9.2. There is a connection. And as you can see, there are 4 marks for the first one, another 4 marks for the second one. Right? It's quite a lot of marks. Right? So the next thing now is, I'll take this equation here. Since the question here says, calculate the x coordinate of B, the maximum turning point of F. The x coordinate is referring to the value of x here. The value of x here. Okay? Point B is a turning point, or it's a stationary point. Turning point, stationary point is the same. Okay? Stationary point is a calculus term. In the past, grade 10 and 11, you were used to turning point. But now that you are in grade 12, you are doing calculus, sometimes you won't see the word turning point, you might see stationary point. Okay? So don't get confused, it's the same thing. Now here, all we have to do is find the first derivative. Okay? Find the first derivative. Equate that derivative to 0 and solve for what? For x. The first derivative of a cubic function is a quadratic function. I'm going to repeat that. The first derivative of a cubic function is a quadratic function. I'm going to talk about it in more detail today. Right? So from here now, let me go to the next page. Right? I'm going to put those values. I'll take that equation. All right? So let me just create it. So 9.2, all right, instead of me writing my equation in terms of f of x, I'm going to carry on with y. So it's y equal to, but I want to show you something. Y equal to x cubed minus 3x squared minus 6x plus 8. All right? Remember, I told you that the derivative has more than one notation. It is also m, which is the gradient that we were taught in grade what? 9 for the first time. It's also f prime of x. It's also dy over dx. Okay? So here, when I find the derivative here, I'm going to use dy over dx for the notation of the derivative. So my derivative will be dy over dx. Then we use rules to determine the derivative of each term. So we have a 3 here, the coefficient is a 1, so we end up having 3x, then we subtract 1 from that, we get 3x squared. Let me warn you, by now you need to be a master of finding the derivative using rules. You need to be a master of finding derivatives using rules. Then 3 times minus 2, that will give me minus 6. Then you subtract 1 from that 2, you get minus 6x. The derivative of a constant times a variable, I told you, is the coefficient or the constant. So this would be minus 6. The derivative of a constant is 0. Alright? So if you take the question, you must have that derivative. If you use f prime of x, then you must have f prime of x equal to 3x squared minus 6x minus 6. I'm just going to add here and write that this is the same as f prime of x. It's also the same as the gradient m. Alright? Then the next thing that I'm going to do is equate that derivative to 0. So if I, okay, it's supposed to be 8 there. I put minus 6. Sorry, I confused myself. Sorry. Right, I'm going to rewrite it. Okay, 6. So from there we say 3x squared minus 6x minus 6 equal to 0. Right, now this is a quadratic equation. You did quadratic equations since grade 9. Right? The good thing about this one here, if you can't factorize, use the quadratic formula. With the quadratic formula, you never go wrong. Okay? If you can factorize and you have the confidence that you can factorize, then do so. But not all quadratic equations can be factorized or can be solved by factorization. This one, it can be solved by, I doubt it can be solved by factorization. But let me use the quadratic formula. So if I use my quadratic formula, it will be x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. When you write metric, this quadratic formula is provided. But I would advise you to memorize it. Let it be part of you. Okay. All right. So x will be equal to, our b is negative. So I'll end up having minus, open bracket, minus 6. Remember, I told you that the quadratic formula has got this minus as part of the formula. It has got that minus, which I highlighted in blue, as part of the formula. If the b is negative, then you must put it in brackets as I did here, like that. There's no need to get confused, no need to make a mistake. Right? Then from here, we say plus or minus the square root of b squared, which will be minus 6 squared. And your b, if it's negative, you must put it in brackets. I've seen in the past a case like this. Someone puts minus 6 squared like this. Minus 6 squared, like that. That's wrong. You get a negative 36 there instead of a positive 36. And you come out of the exam and say, I got it, when it's wrong. Minus 4. All right. The A is 3. Our C is minus 6. All over 2 times 3, which is 6. So this is what you are expected to do. And it's not difficult. You can make it difficult on your own. Then, let me simplify this further. So from here, I'll get 6 plus or minus the square root of 36. Now that will be 12 times 6, so I'll get 72 here, all over 6. Okay? 36 plus 72, that will give me 121. 108. It will give me 108. Okay. So you get 108. Alright, so you end up with x equals 6 plus or minus the square root of 108 over 6. Now what this means, because 108 is not a perfect square, it means you are going to get values of x that are decimals. When you are doing calculus, it is possible that sometimes the x-intercepts, the x values, extension points can be decimal, if you do everything right. So what will be the two values? X will be equal to 2,73 or negative 0,73. Right. Now, I'm sure you can see that we got two values. But the stationary point that we are dealing with here, it's in the second quadrant. So which of those two values of x would you choose? You choose the negative one. All right? So you say, therefore, this one here is the one that you want, means this one is not applicable. So you say, therefore, x is going to be equal to minus 0.73 at b. Then you are done. Okay? Then you get your full marks. Okay, wait. The question, listen. Can you pay attention, please? You were not here yesterday. So you are the one who is supposed to be paying attention more. Right? Alright. And by the way, be very careful. I hope you know that I know all of you. I hope you are aware. If you are not here, I will know that you are not here. Alright? Okay. The question says, calculate the x coordinate. The x coordinate. The question is not saying calculate or determine the coordinate of b. If it says coordinate of b, then you need to find the y value. Here it's very specific, the x coordinate. Okay? Yes? Hey, can you control yourself? Control yourself. We all make mistakes, even myself, I also make mistakes. Hey, listen. Let's just seal this. What answer are you all getting? Alright, let's get on. Alright. Then question 9.5. Alright, what I did. Okay. Wait. Alright, because 9.3 is going to be part of what I'm going to talk about today. And 9.4. Right? For now, I'm going to skip them, but I'll come back to them. Right? Because I need to introduce those concepts. Right? You're going to come back to this? Yes, I'll come back to 9.3 and the 9.4. Alright, so allow me to do 9.5. 9.5. Alright. The question now says, for which value or values of x is f of x concave upwards? Concave upwards, which means we are talking about from somewhere there going that way. That's concave up. Remember, if the graph is concave up, it's happy. Remember that. If the graph is concave up, it means it's happy. If it's concave down, then it's very sad or it's unhappy. Okay? Alright? So, if you want to find the values of x for which the graph is concave upwards, you need to know the x value at the point of inflection. I've taught you two ways of finding the x value at the point of inflection. Two ways that I taught you. Using the second derivative and also using the average of the x values at the turning point. Can I have your attention? Stop talking. Now, in my case here, I'm going to do it both ways. So the first method, I'll use the second derivative. So I'll write here method 1. Okay? Method 1, I'm going to use the second derivative. My second derivative, remember, is the second derivative of the original cubic function. So all I have to do is find the derivative of this. Okay? Find the derivative of that. That's the second derivative of this function here. Okay? So it's going to be 2 times 3, which is 6. Then you subtract 1, you get 6x. The derivative of a constant in a variable is minus 6. Are you following that? Yes. So you get 6x minus 6. Okay? 6x minus 6. Now, I want you to be aware that here now, I can write f double prime of x is equal to 6x minus 6. There is also a notation for the second derivative using dx and dy. But at this stage, I don't want to confuse anybody with it because it's a little bit more complex, right? So I'll use f double prime of x. Then do you remember what I said regarding the inequality for concave up?
Yes.
It's greater than. So say f double prime of x is greater than 0. Okay? If you know this inequality, I can tell you if you get any question on concave up, you write it whilst you're smiling. I'm telling you, your heartbeat won't increase. Listen, it won't increase because you saw the word concave upward. No. You'll be smiling. Alright? So we substitute that second derivative, and then we'll end up having a grade 10 inequality. That's a grade 10 inequality. Grade 10 inequality. Okay? You take minus 6 to the right, you will get 6x is greater than 6. Then you divide both sides by 6. So x will be greater than 1. Then you get your 2 marks. Right? So this is method what? Method 1. I'm going to do it for the second time with a second method. The second method requires you to know the value of x at the point of inflection. Right? So here, what I'm going to do is, just allow me to do this, please. Right? I'm not going to use the derivative, but I can use the derivative to find the value of x. So maybe I end up having to show you 3 ways of doing it. Right? Yeah. Let me do it now. Listen. Let me do it now. Only for today. Listen. Only for today, I'll show you 3 ways. Right? The other 2, method 2 and method 3, have a different way of finding the x value at the point of inflection. So let's go to method 2. Method 2. Method 2, can I have your attention? I know that my second derivative is equal to 6x minus 6. Can you do yourself a favor and pay attention? Alright. I want you to pay attention carefully. So here we equate the derivative to 0. Why are we doing this? We want to determine the value of x at the point of inflection. Well, the value of x at the point of inflection is our reference point. So this becomes 6x minus 6x equal to 6. Then we divide both sides by 6. So you get x equal to 1. Okay? Which means the value of x at the point of inflection is a 1. Alright? Then you go to the graph. Right? Go to the graph. Here. Once you are at the graph, we can approximate where 1 is. Okay? 1 is here. Because there's an x-intercept there. So our point of inflection is on the x-axis for this question. For the graph to be concave up, it means we are talking about values of x that are to the right. Am I right? Yes. The values that are to the right of what? Of this point here. If x is 1 here, it means all the values to the right are what? Are greater than 1. So, your final answer here, you can just write and say, therefore, x is greater than 1. Okay, but you have to do all this working up. But now, the thing is, if you know how to write this answer straight away, you get full marks. Okay, first you need to know the value of x at the point of inflection. By now, do you see a smiley face here? That's concave up. Okay? And if x is equal to 1 here, surely the values of x to the right of 1 are greater than what? 1. Then you just write x is greater than 1. If it was concave down, I'm sure you can see a sad face here. It means it is concave down if values of x are less than what? 1. Are you following that? At the back, are you following? Top. All right. Okay. Method 3. It's not really important because once I say x is greater than 1, it means we're talking about all the real numbers. Okay, if you write x greater than 1, but x is an element of real numbers, you still get full marks. There's no difference. No. Here, it's not that important. If you just write x is greater than 1, it's fine. Okay, because we know that the numbers that we are dealing with are what? Real numbers. All right. Okay, method 3. All right, do yourself a favor, listen and pay attention whilst I talk about method 3. So that in the near future, if you see a question in concave up and concave down and you don't get it right, you have no one to blame. Okay, so here, there's this third method. We need to find the value of x at the point of inflection. For us to do that, we can just find the average of the x values at the turning points. You see here, the value of x here and the value of x there, if we find their average, it will be equal to the value of x at the point of inflection. That's another method. The good thing is, we found those values. See these two here, this one here, and that one. Those are the values of x at the turning points. So if I add 2,73 plus minus 0,73 and I divide that answer by 2, I must get the value of x at the point of inflection, which is what's going to happen here. All right? Are you following?
Oh, yes.
All right. So x will be equal to x1 plus x2 over 2. We have got 2,73 plus minus 0,73 all over 2. Okay? Don't be surprised as to where I'm getting those two values, 2,73 and minus 0,73. They are the x values at the stationary points, or the x values at the turning points. Okay? So this will give me 2 over 2, and I'll get x equal to 1. Then I can say, therefore, x is greater than 1. That will be my final answer. Okay? So I've shown you 3 ways of doing the question. Surely you must at least grasp 2. You must grasp 2 methods, not 1, 2. Okay? Sometimes a question like this, we have 3 marks. Sometimes maximum 3, minimum what? 2. In most cases, this question is if you have a minimum of 2 or a maximum of 3 questions. Is there anyone who has got a question?